Hello everyone, in this video we are going to discuss exercise 3.1 and 3.2. If you didn't watch the real numbers and sets, the link is in the description, watch it. Okay, the first question is, in P of x is equals to 5x power 7 minus 6x power 5 plus 7x minus 6. He gave one polynomial and he is asking what is the coefficient of x power 5. So coefficient is nothing but he is asking for x power 5. So before x power 5 what number is there, that number is nothing but the coefficient. So in this case, before x power 5 minus 6 is there, so coefficient of x power 5 will become minus 6. Next, what is the degree of P of x? So total polynomial is considered as P of x, then what is the degree of that particular given polynomial? So every term 5x power 7 minus 6x power 5 plus 7x minus 6. First let us find degree of each and every term. Here for the first term power is 7, so the degree is 7. For the second term power is 5. For the third term here x power nothing is there, means 1. So power is 1. Here 6 is a constant. For constant the degree is 0. Now out of all the powers, which is the biggest? 7 is the biggest, so that biggest power will become the degree of the total polynomial. So the degree of this polynomial is 7. Next, third question, what is the constant term in the given polynomial? Now constant is nothing but where the term has no variables, or in our words simply alphabet should not be there. Here x is there, so this is not a constant. Here variable x is there, so this is not a constant. Here variable x is there, so this is not a constant term. Here the last term is not having any variable or any alphabet, so this is the constant term, here including the symbol. So minus 6 is the constant term. Okay, next the second bit is stating true or false. First question in this, the degree of the polynomial root 2x square minus 3x plus 1 is root 2. He gave one polynomial and he said that the degree of that particular polynomial is root 2. So let us check whether this statement is true or false. First term if we observe, for x the power is 2. For second term if we observe, for x nothing power is there, means 1. The last term, that is the constant, always the constant degree is 0. So now 2, 1, 0. Out of these three powers, the maximum is 2. So the degree of the total polynomial is 2. But whereas he said that the degree is root 2. So the given statement is false statement. Next, second question. The coefficient of x square in the polynomial P of x is equals to 3x cube minus 4x square plus 5x plus 7 is 2. So coefficient of x square coefficient is nothing but the number which is there before the x square. If we observe this term, before x square minus 4 is there, so the coefficient of x square is minus 4, but he gave it as plus 2. So this statement is false statement. Okay, the next question is, degree of a constant term is 0. So let us check. Any constant term, simply number, I am taking some constant term, that is 2. So this 2 I am writing it as 2 into 1, and we know one formula, a power 0 is equals to 1. Any number power 0 is equals to 1. So in the place of a I can write like this also, x power 0 is equals to 1. So now 1 is exactly equals to x power 0. So 2 into, in the place of 1, I will write x power 0. So if we observe this, for the variable x, the power is 0. So the degree of this constant is 0. Yes, he also gave it as 0 only. So this statement will become true statement. Okay, the next question. 1 by x square minus 5x plus 6 is a quadratic polynomial. So what is the definition of polynomial? An expression whose power is non-negative integer. This power should be non-negative integer. Then that expression is called as a polynomial. So if we observe this, 1 by x square minus 5x plus 6 can be written as x square minus 5x plus 6 whole to the power minus 1. So if we expand this, there is no chance that we will get a positive power, because the whole power is minus only, so compulsory we will get a negative power only. So we know very well that polynomial should be having a non-negative integral power, but here we got a negative power. So this is not a polynomial at all. So but he gave it is a quadratic polynomial. So this statement is false statement. Okay, the next question is, the degree of a polynomial is 1 more than the number of terms in it. So I am writing some polynomials. 2x square, 7x power 4, 7x power 4 plus 7x square, 100x power 99 plus 2, x power 77 plus 1. So these are some polynomials I wrote. Now for each and every polynomial, let us find the degree. Here only one term is there, so the power will become the degree 2. Here also only one term is there, so power will become the degree 4. Here two terms are there, so for the first term power is 4, for the second term power is 2. Out of 4 and 2, 4 is the biggest, so degree will become 4. Next, here for the first term power is 99, second term is a constant, so constant term degree is 0. So out of this 99 and 0, the biggest is 99, so degree will become 99. Next, here the first term having a power 77 and the second one is a constant, so it is 0. Now out of this 77 and 0, the biggest is 77, so the degree will become 77. Here all polynomials, and here I wrote all the degrees. Now if we compare how many terms are there and what is the degree. Here one term is there, degree is 2. Here one term is there, but degree is 4. Here two terms are there, degree is 4. Here two terms are there, but degree is 99. Here two terms are there, the degree is 77. So from this we can conclude one thing, that is degree of a polynomial and number of terms in a polynomial are not connected. It means degree of a polynomial and number of terms in a polynomial does not have any connection at all. Even one term is there but degree is 2, one term is there but degree is 4. So according to the question he gave, degree is 1 more than the number of terms in it, so it is completely false statement. Number of terms and degree of the polynomial are completely different to each other. They don't have any relation. Okay, let's move to the third bit. If P of t, polynomial in terms of variable t, is equals to t cube minus 1, then find the values of p of 1, p of minus 1, p of 0, p of 2, p of minus 2. P of t is given as t cube minus 1, and he is asking the value of p of 1. P of 1. Here p of 1 is nothing but in the place of t we need to substitute 1. So we will get, here t is there, so 1 cube minus 1. 1 cube 1 minus 1. 1 minus 1 0. Next p of minus 1. Same again, in the place of t we need to substitute minus 1. So minus 1 power 3 minus 1. Minus 1 whole cube minus 1 minus 1. Minus 1 minus 1 minus 2. Next p of 0. In the place of t we need to substitute 0. So 0 power 3 minus 1. 0 power 3 0 minus 1 as it is. 0 minus 1 minus 1. Next p of 2. In the place of t we need to substitute 2. So 2 cube minus 1. 2 cube 8. 8 minus 1 7. Next p of minus 2. Minus 2 whole cube minus 1. Minus 2 whole cube minus 8 minus 1. Minus 8 minus 1 minus 9. So these are the values of p of 1, p of minus 1, p of 0, p of 2, p of minus 2, where p of t is given as t cube minus 1. Okay, let's check the next question. Check whether minus 2 and plus 2 are the zeros of the polynomial x power 4 minus 16. So the polynomial is given as x power 4 minus 16 and he is asking minus 2 and plus 2 are the zeros or not. So it's very simple. When we are checking minus 2 is a 0 or not, substitute minus 2 in the place of x. Here in the place of x write minus 2 whole power 4 minus 16. Minus 2 whole power 4 is nothing but minus 2 into minus 2 into minus 2 into minus 2. Minus into minus plus, plus into minus minus, minus into minus plus. 2 2s are 4, 4 2s are 8, 8 2s are 16. So minus 2 power 4 is nothing but 16. Minus 16. 16 minus 16, 0. So when we substituted any number in the place of x in the given polynomial, if we got the answer 0, then the substituted number is the 0 of the polynomial. So here we substituted minus 2, then we can say minus 2 is the 0. Minus 2 is the 0 of the given polynomial. Next, he is asking about plus 2 also. Now, in the place of x, we need to substitute plus 2. The given polynomial is x power 4 minus 16. Now, we are checking plus 2 is a 0 or not. So, in the place of x, substitute plus 2. 2 power 4 minus 16. 2 power 4 is nothing but 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 2s are 16. So 2 power 4 is nothing but 16. So in the place of 2 power 4, 16 minus 16 as it is. 16 minus 16, 0. So we got the answer 0. Then the number which we substituted plus 2. 2 is the 0 of the given polynomial x power 4 minus 16. Okay, let's move to the last problem in exercise 3.1. Check whether 3 and minus 2 are the zeros of the polynomial p of x when p of x is equals to x square minus x minus 6. And he is asking 3 and minus 2. So simple, when we are checking for 3, substitute 3 in the place of x. When we are checking minus 2, substitute minus 2 in the place of x. First, I am going with the 3. P of x is equals to x square minus x minus 6. Now, I am substituting 3. So, P of 3 is equals to, in the place of x, substituting 3. 3 square minus, again in the place of x substituting 3, minus 6, which is equals to 3 square 9 minus 3 minus 6. 9 minus 3, 6 minus 6 as it is. 6 minus 6, 0. We got the answer 0. Yes, then plus 3 is the 0. Next, p of x is given as x square minus x minus 6, and we are substituting minus 2. So p of minus 2. In the place of x substituting minus 2. Minus 2 whole square. Here minus is there, so that minus as it is. Now in the place of x again minus 2. Minus 6. Minus 2 whole square plus 4. Minus of minus 2 plus 2 minus 6. 4 plus 2, 6. 6 minus 6, 0. Here we got the answer 0. Then we can say minus 2 is also a 0 of the given polynomial. So from this we can conclude 3 and minus 2 are zeros of p of x. P of x is nothing but the given polynomial x square minus x minus 6. Okay, now let us move to exercise 3.2. The graphs of y equals to p of x are given in the figure below. For some polynomials phi of x. So some polynomials are there, for those they did the graphs. In each case, find the number of zeros. So for every figure, by observing it, we need to say how many zeros will be there for that particular polynomial. It is very easy to say from the figure the graph at how many places it is touching the x-axis. That will be the number of zeros. For example, if you see the first figure, this is the graph which he did. This graph is how many times touching the x-axis. This graph is not at all touching the x-axis, so it has 0 number of zeros. Next, this is the graph, and how many times this graph is touching the x-axis. This graph is touching the x-axis at only one point, so this graph is having 1 number of 0. Next, if you observe the third question, how many times this graph is touching the x-axis? Here once, twice and thrice. That graph is touching the x-axis at 3 points, so this polynomial has 3 zeros. Next question, if you observe, this is the graph, how many times it is touching the x-axis? Here once and here twice. So it is touching the x-axis at 2 points, so it has 2 number of zeros. Next question, how many times this graph is touching the x-axis? Here once, twice, thrice and fourth. So 1, 2, 3, 4. So it is touching the x-axis 4 times, so this polynomial has 4 zeros. Next question, how many times this graph is touching the x-axis? Here 1, 2, 3. So it is touching the x-axis at 3 points, so this polynomial will be having 3 number of zeros. Okay, next, second bit is find the zeros of the given polynomials. First, what is a zero of the polynomial? Zero of the polynomial is nothing but which number we need to substitute in the place of x so that we will get the answer 0. So here the first polynomial is given as 3x. In the place of x, which number we need to substitute? After substituting that number, the answer will be 0. So we have only one choice, that is 0. If x is equals to 0, 3 into, in the place of x, 0. 3 into 0, 0. So when I substituted the number 0, I got the answer 0. So we can say that number 0 is the 0 of the polynomial. Next, come to the second question. P of x is given as x square plus 5x plus 6. Here, the given polynomial is quadratic. So, we need to solve this by splitting the middle term into two terms. So, let us check how to solve splitting the middle term into two terms. Constant is 6 into x square coefficient. Before x square no number is there, so it means 1. Multiply those two numbers. Constant into x square coefficient. 6 into 1, 6. Now, in which tables number 6 will come? Write all those tables. 1 6, 2 3, and again 3 2s, 6 1s. So these two are the only possible pairs to get the number 6 if we multiply. Now from these two pairs we need to pick one pair which exactly satisfies the middle term plus when we do subtraction or addition of these numbers. First one I am taking 1 and 6. 1 and 6. Reverse also 6 and 1. So we need to get plus 5 as the answer. So what I need to do for these two pairs so that I will get plus 5? Only one possibility, that is doing subtraction. 6 minus 1 is plus 5. 1 minus 6 is minus 5. Here the middle term is plus 5, but here we got minus 5. So this is the wrong one. We don't want this. And here plus 5 is there. So I need to check again one more thing. Here I substituted plus 6 and here I wrote minus 1. Now we need to multiply these two numbers. 6 into minus 1. 6 into minus 1 minus 6. Whereas our product is plus 6. But here we got minus 6. Addition it is satisfying, but product it is not satisfying. So this is also not the correct pair. Now we can say correctly this 1 comma 6 is not the correct pair. So the remaining is 2 comma 3. Obviously here only two pairs are available. So one pair is not satisfying, means definitely this is the second one is the correct one. So let us take 2 and 3. Okay. The given polynomial to us is x square plus 5x plus 6 and we know that the second pair is 2 and 3. So if we write 2 3 or else 3 2, we need to get plus 5. So only one possibility, that is plus. Because if we do minus, we won't get plus 5. So now here plus 2 I took, here plus 3 I took, and I will do multiplication of these two. 2 into 3, 6. Yes, we got correct answer. Product also plus 6. So it means 2 and 3 or else 3 and 2 is the correct pair. So write the first term as it is, x square plus, in the place of 5x, write 2x plus 3x. 2x plus 3x. Last term as it is again. Now if we observe clearly, first term and second term having x common. So take x common. From x square, x gone means one more x will remain, plus from 2x, x completed means 2 will remain. Now from the third term and fourth term also you need to take some common. After taking common again you need to get the same numbers inside the bracket. Here x plus 2 is there, means here also we need to get x plus 2 only. Now what will be the common that which we need to take? If we observe the third term here, 3x is there. Already inside the bracket x is covered. So remaining is what? 3 plus 3. So x into x plus 2 plus 3 into x plus 2. Now here two times x plus 2 is there. So take that x plus 2 into x plus 2 I wrote already. So remaining is x. X plus 2 I wrote already. So remaining is 3. So the factors are x plus 2 into x plus 3. Now what numbers we need to substitute in the place of x so that we will get answer 0. Here already plus 2 is there. So if I substitute minus 2, here minus 2 plus 2 will become 0. 0 into anything is 0. So one answer I got minus 2. Next, x plus 3 is there. Already plus 3 is there. So if I substitute minus minus 3. Minus 3 plus 3 will become 0. 0 into anything is 0. So the answer is minus 2 and minus 3. Minus 2 and minus 3 are the zeros of the polynomial x square plus 5x plus 6. Okay, next third question. P of x is equals to x plus 2 into x plus 3. Now the question is already he gave factors. So x plus 2 is there. If I substitute minus 2, what we will get? If x is equals to minus 2. In the place of x, let us substitute minus 2. Here plus 2 into minus 2 plus 3. Minus 2 plus 2, 0 into minus 2 plus 3, 1. 0 into 1, 0. So when I substituted minus 2, I got the answer 0. Next, here x plus 3 is there. Already plus 3 is there. So if I substitute minus 3. So in the place of x, minus 3 plus 2 into in the place of x, minus 3 plus 3. Minus 3 plus 2 minus 1 into minus 3 plus 3 0. 0 into anything 0. So when I substituted minus 3, I got the answer 0. When I substituted minus 2, then also I got the answer 0. So we can conclude minus 2 and minus 3 are the zeros of the polynomial x plus 2 into x plus 3. Next, P of x is given as x power 4 minus 16. X power 4 minus 16. We need to convert or we need to change. How to change that one? Simply I will write it as 2 power 4. Because 16, if we do prime factorization, we will get 2 8s are 16, 2 4s are 8, 2 2s are 4. So 1, 2, 3, 4. 2 is there 4 times. So that's why I wrote 2 power 4. X power 4 minus 2 power 4. Now, here already minus 2 is there. So in the place of x, if I substitute plus 2, let us check. If x is equals to plus 2. If x is equals to plus 2. In the place of x, I'll substitute 2. 2 power 4 minus 2 power 4. 2 power 4 minus 2 power 4. 0. Next, then one more thing we need to check. Here the power is even. So if I substitute negative number also, I will get positive only. So what I will do? If x is equals to minus 2. Anyway, I got clarity that plus 2 is the 0. So that's why I am substituting minus 2. So now minus 2 whole power 4 minus 2 power 4. Here the power is even. So negative number. If the power is even, this negative number will become positive number. 2 power 4 minus 2 power 4. 2 power 4 minus 2 power 4 is 0. So when I substituted plus 2 as well as when I substituted minus 2, we got the answers zeros. So when we substituted plus 2, we got answer 0. Whenever we substituted minus 2, we got the answer 0. So from this we can conclude the zeros are plus 2 and minus 2. Okay, the last question is y are 1 by 4 and minus 1 zeros of the polynomial p of x is equals to 4x square plus 3x minus 1. Here 1 by 4 is given. So p of x is equals to 4x square plus 3x minus 1. Now I am going with p of 1 by 4. Simply in the place of x, we need to substitute 1 by 4. So we get 4 into 1 by 4 whole square plus 3 into 1 by 4 minus 1. Here 4 into 1 by 4 whole square. This square is for numerator as well as for denominator. So 1 square 1 by 4 square 16 plus 3 into 1 3 by 4 minus 1. 4 ones are 4 fours are. So we remains with 1 by 4 plus 3 by 4 minus 1. Here both the denominators are same, so we can add the numerators. 1 plus 3, 4 divided by 4 minus 1. 4 by 4 both will cancel, so we remains with 1 minus 1 as it is. 1 minus 1 0. When I substituted the number 1 by 4 in the place of x, I got the answer 0. So that's why 1 by 4 is a 0. P of 1 by 4 value is 0. That's why 1 by 4 is the 0 of the polynomial. Next, one more is also there, that is minus 1. Let us check why this minus 1 is 0. Okay, now we are checking why minus 1 is a 0. So the polynomial is 4x square plus 3x minus 1 and we are substituting minus 1. So P of minus 1. 4 into, in the place of x, minus 1 whole square plus 3 into minus 1 minus 1. Here 4 into minus 1 whole square plus 1 plus 3 into minus 1 minus 3 minus 1. 4 into 1 4 minus 3 minus 1. 4 minus 3 1 minus 1 as it is. 1 minus 1 0. When I substituted minus 1, I got the answer 0. That can be written as P of minus 1 is equals to 0. So P of minus 1 is equals to 0. That's why minus 1 is the 0 of the polynomial 4x square plus 3x minus 1. So that's why 1 by 4 as well as minus 1 both are the zeros of the given polynomial. Till now, if you didn't subscribe to my channel, subscribe for more videos. Thank you.